Okay guys, Stat 1150. What I want to teach you in this video is something called box plots. And first of all, let's talk about this. I have this handout here, and I know a lot of students, students are just different, just like professors and everything else. Some students prefer to, prop up their feet and kick back and just watch the videos. Unfortunately, some people don't watch the videos, and that's not cool. But some people like to, be more interactive and have the handouts in front of them that I'm working on the video. So if you're one of those people, what you should do is you should go to your Blackboard, our Blackboard site, and you'll see that there's a new folder called Handouts. Well, if you click the Handouts folder, you'll see that there's a handout called Box Plots, which is the one that I am working on right now. So you can download that and print it out if that's what you prefer to do. I think if I was a student, that's what I would want to do, but people are different. So guys, what are box plots? As I put here, they are a useful graphical tool for visualizing a distribution, especially when comparing a quantitative measurement over two or more groups. Now, first of all, box plots are specifically for quantitative variables. ACT, SAT, heights, weights. Box plots do not work for things called gender. They don't work for categorical variables, things that we're going to examine in future videos. But, and this is kind of the confusing part, if we have a quantitative measurement such as, just example, ACT score, and we want to examine that the distribution split over, say, male and female, which is gender, then box plots are a perfect tool to do that. But guys, the key is you have a quantitative measure to begin with, and you want to examine it over two or more groups. But you can't start with the groups only. You can do a box plot with just a quantitative measurement, makes them more interesting if you put them over groups, but you got to have the quantitative measurement. So a box plot is a graphical tool for quantitative variables, and it's even more useful when you have this. Another thing that box plots do is they help identify and visualize outliers. Now, outliers are extremely high or extremely low, kind of unusual observations. So, but, and here's the kicker here, they're unusually high or unusually low relative to the distribution from which you are analyzing. So what I mean by that is a value in one distribution may be an outlier where the same value in another distribution may not be an outlier. Let's give an example. Let's say that we're looking at heights of Shawnee State University students. So we're in a class and someone walks in and they are 6'9". Well, that's an unusually tall person for heights of Shawnee State University students. You don't see many 6'9" students walking around. So clearly their height would be an outlier. However, if I was looking at heights of NBA basketball players, then that 6'9" would not be an outlier. So again, the value, the measurement is within the distribution that you're examining. So it's kind of a relative position, if you will, of the value in relation to the other values. Because 6'9" would be probably somewhere around the average height in the NBA, I would think. Maybe a little bit above, but it would be way above the average height for students at Shawnee State University. So there's a rule that we have that helps us create box plots. So potential outliers are often identified by this rule. Observations that are a distance of more than 1.5 times the IQR below or above the first and third quartiles are usually identified as potential outliers. Now, I think when you read that, it's kind of confusing, but I want to do an example, then we'll jump into StatCrunch and go from there, okay? So, all right, so here we go. We've got our data, which I call X, which is scores on a happiness survey. So scores range from 1 is just I guess, just completely pissed off at the world, and 100 is just ecstatic about everything. I think I have friends kind of here and here, at least sometimes. So this person right here has scored a 35. This person right here scored a 1, and so on and so forth. Okay, so to create the box plot, we need to arrange the data in ascending order. First step is going to be able to find these 5 numbers, the summary. I'm sorry, the 5-number summary, which is the low value, Q1, the median, Q3, and the high value. So guys, this is known as the 5-number summary. Again, the lowest number, the first quartile, the third quartile, the median, and the high number. Okay? The next thing we'll do is we'll use this rule up here that we established earlier to find the outliers, and then ultimately what I want to do is create this I should say use this information to create a box plot. Then we're going to jump into StatCrunch and see the way that you typically do this stuff. So find the 5-number summary. So you can see what I did. I took these 20 numbers and I arranged them from low to high. So I know that the median is going to be, since I have an even number of data, it's going to be the average of the 10th and the 11th number. So again, step 1, I need to find the low, Q1, the median, Q3, and the high value. Well guys, the low value is easy. The high number is easy. The median, let's find it. So this is the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th. So I take the 10th and the 11th piece there. 85 plus 85 divided by 2 gives you 85, so we know that the median is 85. Now I'm going to take the numbers below this and take the numbers above that and come in and find Q1 and Q3. So I have 10 numbers below, so I know I'm going to take the median, the average of the 5th and 6th, so 1, 2, 3, 4, 5. So I'm going to take the average of the 5th and the 6th, which is 67. So that's Q1. And then I'm going to take the average of the 5th and the 6th above the median. So 1, 2, 3, 4, 5. 5 and 6 is here. So that's going to be 92.5. All right. So that's the 5-number summary. So I really wish my text or my wife's text wouldn't come through there, but they are, and I'm not going to restart this video to turn that off. Or maybe I will. Looks like she's got some cool stuff going on. I don't know what she's doing, but she's signing people up for something. So the next thing we'll want to do is we want to find the outliers. So to find the outliers, what do I need to do? Well, first of all, I need to find the 1.5 times the IQR. Well, that's pretty easy, isn't it? The IQR is Q3 minus Q1. So 92.5 minus 67, if my mental arithmetic is correct, is 25.5. I'll tell you what, let me grab a calculator just to make sure. So we have 92.5 minus 67. So 25.5, I multiply that by 1.5, and I get 38.25. The next thing I have to do is, again, use this rule. Distance of more than 1.5 IQR below or above the 1st and 3rd quartiles. So I need to take Q1 and subtract 1.5 times the IQR. And I need to take Q3 and add 1.5 times the IQR. So Q1 is 67 minus 38.25. And that's 28.75. And then I need to take Q3, which is 92.5, and add the 38.25. and I get 130.75. Now, what I can do with these two numbers is I can kind of think of this range from 28.75 all the way up to 130.75 is kind of the normal range. So anything that I have in my data set from here to here is not an outlier. But anything I have below 28.75 or anything I have above 130.75 is an outlier. So what I can see is I can come in here at the 28.75 would fall about in there someplace, wouldn't it? So I have 1, 2, 3 outliers because these 3 observations are below the cutoff of 28.75. I don't have anything above 130.75, so I don't have any outliers up here. So if I want to take this information and construct a box plot by hand. Now guys, I know if I'm ever going to do a box plot, I'm going to go to StatCrunch and create a box plot like I'm going to show you later in this video. But I just want to show you how to do one of these by hand just so it makes more sense when we get to StatCrunch. So the first thing I would do is I would want to set up the axis for my box plot to range from 0 to 100. So I would probably just start a line here. I'm going to do what's called a horizontal box plot, although we could do a vertical. Draw the line this way. So I'm going to go 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So this is my focus on the happiness scale that we want to take a look at. Now, what I'm going to do is I'm going to come in and draw 3 lines. First of all, I want to draw 3 lines for my Q1, the median, and Q3. So I want to come in approximately 67, which would be about right here, and I want to draw a line. Next, I want to come in at the median, which is 85, and I want to draw a line. So that's approximately down to 85. Then I'm going to go to 92.5, which is about right there, and I want to draw a line, and then I want to build in a box. Now, if I don't have any outliers above Q3, I'm going to draw a line up to the highest value, which, if we look back at our data set here, we see that that goes all the way up to 100. So I've got 100 right here, which I'll draw my line out to there. So I have the upper part of the box plot taken care of. Now the bottom part, because we have outliers, is more complicated. What I'll do now is from the value of Q1, I'm going to draw a line down to the lowest value, which is not yet an outlier, but the next value is. So when I come down my data set, I can see that I'm not an outlier all the way down to 35, but the next value of 19 is an outlier. So I'm going to draw this down to 35, which is about right here. And then to indicate these values are unusual, I'm going to make points for those. So I'm going to come in at a 19 and make a point. I'm going to come in at a 3 and make a point. And I'm going to come in at a 1 and make a point. So guys, when you see a box plot that has these isolated dots, these points, these things are outliers. This value, 35, is the lowest value in the data set, which is not yet an outlier. See, if this was an outlier, I'd have a dot there. But I don't. It's connected to the main frame of the box plot, which means it's not unusually small. We don't have anything unusually large because if we did, we'd have a dot up there. So I connected all the way up to 100 because 100 is not an outlier. It didn't fall above the cutoff for being, again, normal versus an outlier. Okay? So, yeah, and I guess the beauty of this is if you're ever going to do construct a box plot, you're going to use technology, a graphing calculator. For us, it's going to be StatCrunch. But I think it really helps to go through one of these by hand just to show what we have. So what do we know? Once we've got this box plot, what do we know? Well, it kind of cuts our distribution into 25% ranges. So I can see that the variability in the bottom 25% is a lot more than the variability in the upper 25% just because of the distance we have from Q3 to the top value, from Q1 down to the very bottom value. Notice that in the box we have the middle 50%, so this distance from here to here is the IQR, because it's the range of the middle 50%. So I can see that the variability in the top 50% is much less than the variability in the bottom 50%. So that's kind of the things you're looking for. And I can tell right here that this is a left skewed distribution. If I were to do the box or the histogram here, I'm going to expect to probably get something like this because these outliers are going to correspond with these values right here. So I can look at this and see that this box plot, because of these outliers, is going to have a tail going to the left, which creates a left-tailed distribution. So what would a box plot look like with a symmetric distribution? Well, the box plot would be symmetric. The left and the right sides would look the same. This would correspond with a histogram. They would look something like this. And you can generalize from this what a right skewed distribution would look like. Just take that and flip it and put the outliers up here. Flip the flip the histogram, and you've got just a reverse illustration of a right skewed distribution where the outliers would be to the positive side, not to the negative side. Because guys, remember, when we go this way, we're getting toward negative numbers, aren't we? So, and we're also going toward the left. So that's why we call it a left or a negatively skewed distribution. When we go this way, we're going right skewed, and we're going toward the positive numbers, positively skewed distribution. So the way the tail is going defines the name of the distribution. Tail's going to the left, it's the left skewed distribution. It's a negatively skewed distribution. The tail's going to the right, it's a right skewed distribution or positively skewed distribution. All right, guys, what I have done now is a couple things. I don't want to do this just yet, but I do want to look at a data set that I've uploaded. So guys, if you go to Content and go to Data Sets, you'll see that I have a happy data set, and I've downloaded it here. So I want to open it up. And what you can see, what I've done here, let's get a little larger here. What I've done is I have these happiness scales just like I did before, but I've given the first 10 as a female score, and I've given the last 10 as a male score. So I may be interested in just looking at the happiness scales as a whole, or I may be interested in looking at the happiness scale across gender. So what I want to do is I want to save this on my desktop so it's easy to find. Now once I get that, what I want to do now is I want to go to my stat lab, go to StatCrunch, and I want to go to the website, and I want to select a file on my computer. So let's go get the happy. And we'll go down and we will open it up. All right, gang, the first thing I need to look at when I get this data set in is it in the correct form? In other words, when I look at row 5, does that row contain information on the same person? Well, yeah, that person is a female and they have a happiness scale of 19. Now, we only have 2 variables on each of the 20 individuals here, but we could have, 3, 4, 5. We could have, I've seen data sets with thousands of variables. So stacked data would have all the happiness. We would have happy for male and happy for female in 2 different columns. That's not what we want. We want this in proper format. All right, so we've got that. So the very first thing I may want to do is may want to go in and just look at a box plot just for the happy scale and not even consider the gender. Okay, so use fences to identify outliers. And do we want to draw it horizontally? That's the way I drew mine. And what I'll do is I'll show you both ways. And for the most part, let's just compute. Now, when you compute this, you'll see that we end up getting a box plot that looks a lot like what I constructed by hand. First of all, you got the nice properties. You can click this and you can see that value is from row 2, who had a happiness scale of 1. This point right here is row 18. So that's this person right there. And you can see when you click it, it turns pink. I'm not colorblind. This one right here is row 5. You can come in and click the box plot. I call it the main frame of the box plot, and you'll see it gives you the IQR, the lower limit, Q1, the median, Q3, upper limit, and it shows us we have 3 outliers and 20 values. Should be able to go right there and get the same thing. I think if we come right here, no, it gives us the same thing at all major places of the box plot. Now, that's fine and dandy, isn't it? And there's a lot of times that we want to just look at the, let me clear this out. There's a lot of times we just want to look at the box plot just for the measurement and not even consider gender. But let's say that we want to consider gender. So I would go into box plot. I would still choose happy, but now I'd want to come in and group by gender. So that's the 2 or more cases, back to the definition of visualizing a quantitative variable, happy, over 2 or more groups, gender. So I want to use fences, always. I'll tell you what, I'm not going to do this horizontally. I'm going to do the default, which is vertical. All right, so let's compute. And much quicker than doing it by hand. You can see that we have the box plots created very efficiently and fast. Now, this is a good example. Notice that when we compare the distributions, only the male happy of 3 emerges as an outlier, because these outliers are recalculated separately for males and females. We had 3 outliers when they were all combined, but when we separate it across gender, we only get 1 outlier. So this male over here is extremely mad about something relative to the other males for which the data was collected. So what kind of stuff do I notice here? Well, I noticed that the happiest person was a male. I noticed that the Q3 for male is higher than the Q3 for female. I noticed that the medians are almost equal. I notice Q1 is higher for the male than it is for female. And what I really notice is I notice that the spread in the lower 25% is a lot more than the spread in the lower 25% for females. So the spread in the lower 25% for males is a lot more than the spread for the lower 25% for females. I also notice that the IQR is higher for females because this distance from right here up to there is more than this distance to right here, so the IQR is higher. And you can see that. The IQR here is 55. The IQR over here is 29. So you can see that just by grabbing the summary statistics off of the chart. So what can I conclude here? Are males happier than females? Well, for these 10 males versus those 10 females, overall, I don't know, because the medians are about the same. The median there is 85.5. The median over here is 84.5, so the median is actually a little bit lower. So I guess it's just the way you look at it, right? A lot more variability in happiness across females than you get across males. So I'm saying that standard deviation is going to be a lot. Well, actually, the standard deviation is going to be pretty close, actually, because I keep forgetting this guy right down here. He really contributes to the variability. But one person will have less contribution than 25%. So we'll take a look at that maybe in just a second. So if I do want to take a look at the numerical summaries, remember how we do that? Just go to Stat, Summary Stats, do columns, and look at happy and group by gender. And let's go through and pick what we want. I want the mean. I want the standard deviation. Okay, so shift, click. The mean, well, I don't know why I'm having so much trouble with this. Shift, command, okay, what am I doing here? Mean, so shift plus click. I don't have a click. So shift, standard deviation, median, and IQR. So let's just take a look at these. So we saw the medians and the IQR. The standard deviation for female was higher, and the mean was higher for males. So the average for males is higher than females, but the variability is higher for females than for males. Okay, so gives you a little bit more. Now, guys, one thing I do want you to remember, and I see a lot of students say this, and this is a place where I'll go ballistic on you if you do. They'll get a box plot and they'll look at it and they'll say, yeah, the average is higher for females than males. Guys, box plots don't have anything to do with standard deviation and the average. Box plots deal with medians and quartiles and IQRs and 1.5 IQRs and things like that. Now, I can look at this and kind of generalize and say, well, I think the standard deviation is going to be higher, and I can say that I think the mean is going to be higher, but you can't conclude that for sure. You have to actually go to your summary statistics. The box plots only give the 5-number summary and the outliers. Q1, Q3, the median, the low, the high, and of course the way we calculate outliers. Okay? All right, guys, let's go back to the handout. And if you look on the second page of the handout, it says we're going to work problem 3.46. So the number of alcoholic drinks per week is given for 45 adult men and 36 adult women who drink. The data are at this text website. So guys, we're going to go get the data for 3.46 and get it ready to analyze. So I want to go data sets from your textbook. 3.46 tells me it's in chapter 3. And I want to go to homework. So guys, I come down to exercise 3.46 and I click it. And what you can see is I have the data set I described earlier. I have the number of drinks per week for female, and I have a number of drinks per week for male. But guys, is this in the format that we want? When I read left to right on a row, is that information and that information on the same person? Well, obviously it can't be, because this 8 comes from female and that 18 comes from a male. So guys, what I got to do is I got to get my data in the right format. So guys, what I have is I have to set up a stacked data situation. So I go to data, I go to arrange, and I go to stack. Now I want to select both columns. I'm not really worried about my ID column, but I want to store my labels. Now I want to name my labels something appropriate or corresponds at least to the measurements I have. And I'm just going to call it drinks, because that's what we're measuring here, number of drinks per week. No, I'm sorry, it says store labels. Guys, our labels are gender. My bad. We want to store values, so that's going to be drinks. And store IDs in, let's just call it ID. All right, so we're going to compute. And we can see that we've added 2 new columns, and we now have our situation where when we click a column here, we know that this person is female and they drink 6 drinks per week. These 2 columns right here, male and female, are irrelevant, so I want to get rid of them. Okay, I want to, how do I want to do this? I want to shoot. Actually, I want to go to edit, don't I? Yeah, here we go. So I want to go to columns, and I want to delete. And I want to delete male and female. All right, so guys, now I have my data set the way I want it. Again, I come to a row 23. I see that I have a female that drinks 4 drinks per week. I want to clear all this out so I can run my data analysis. Now, if you go back to your handout, and I can do that. Let me, I think this would be probably a pretty good time to do that. Now let me escape and get this so we can all see the same stuff. Alright, so compare the median number of drinks for men and women. So guys, I'm just going to go to summary stats, column, and I'm going to compare the drinks across gender, and all I want is the median. So the median for females is, for men, is 9, and women is 5. So the median number of drinks for men is quite a bit higher than the median number of drinks for women. Now, can we conclude that men are more alcoholics? No. Let's just report the numbers and leave the interpretation to other people. Compare the IQRs for the 2. All right, so again, that's going to be easy to do. Go to stat, go to summary stats, go to columns, and go to drinks, group by gender, and we want to do the IQR. Well, that's weird. Huh. Well. Surely not. Okay, median 5 and 9. Well, I am shocked. The IQR is 5 and 9. That's strange, but so the IQR. Now, guys, don't generalize from that, because your IQR is almost never going to be the same as your median. But this is just one of those cases where something kind of freaky happened. All right, next thing we say is complete the chart. So I want the mean, the median, standard deviation, and IQR across men and women. So I can go to stat, summary stat, do drinks, group by gender, and start putting in what I need. So I can go standard deviation, median, and what else did I need? IQR. All right, so the mean for males is 11.67. The mean for females is 5.86. So on average, it looks like males drink almost twice per week what women do. The median are 5 and 9. No, my bad. And guys, when you report summary statistics, be consistent with your rounding. We typically round these things to the hundredths. The IQR, we can go ahead and say 5.0. Guys, this is just freaky. No, messed up again. I hung up on this IQR being the same as the median, because that's just weird. That almost, I've never seen that happen. So. Don't generalize there. Standard deviation for men is 12.19, and the standard deviation for women is 4.80. So you can see there's a lot more variability in males and in males than there is female. Plus the average is a lot higher too. Plus the median and the IQR are higher. So both measures of spread, the two measures of spread here, the standard deviation and the IQR, both of these measures are higher for males than for females, indicating there's more variability in number of drinks across for men than for female. Our two measures of center or central tendency or typical score, both of these, the average and the median, are higher than the average and the median for women. So the higher values go to the men. So it looks like men drink more per week than females. Now, what we can do now is we can go in and take a look at the box plot. I think it's worth it. So go to drinks and let's group by gender. So let's go both of these again. And you know what? I think it's pretty clear what we're going to get, right? What we get is, again, more variability in male. Most of the variability in male is because of the people who drink a lot. I mean, look at the upper 25%, how much variability there is versus the upper 25% for females. The lower 25%, there's more variability for males than there is females. So I would say that the drinking across females is more consistent than it is across males. Males tend to either drink a lot or not drink much at all. All right, so let's go back to the handout here. Remove the outliers of 70 and 48. All right, so let's go do that. So 70, I want to remove that. All right, how do I clear that? Well, I go to edit and go to row, and I want to delete. And I also want to get rid of what, the 48. So I'll go to 48, edit, row, and delete. All right, so I want to rerun the values. So I go to stat, I go to summary stat, I go to column, drinks, gender, and I want to choose all right, what happens? The mean for males went to 9.47. The mean for women was 5.86. You know, it's not bound to change because the values that we deleted weren't females, so all of that's going to be the same. So 9.47, the median remained at 9. The IQR remained at 9, and the standard deviation changed to 6.19. So notice what changed. What changed were the mean and the standard deviation. These things were, you might say, artificially inflated, or at least inflated, because of two scores. But when we removed those really high scores, these things became closer. In fact, they decreased. So that kind of goes back to the last video where we talked about the effect of outliers, how outliers don't have a lot of effect on the mean and the IQR. I'm sorry, the median and the IQR, but outliers do have a lot of effect on the mean and the standard deviation. So again, what can we summarize? In the presence of outliers, the median and IQR are more stable measures of center and spread. Of the typical score and the variability. Let me make that a bit larger so you guys can see it if you care to. So that's what I take from this. When I remove the outliers, the median and the IQR for males remained the same, but the mean and the standard deviation changed quite significantly. So, guys, that's all I got on this video. Hope you've watched it all the way through. It was an important video. So, all right, take care.